Hello, let us study about sound. In this tutorial, we'll study about ultrasonic sound, the uses of ultrasonic waves, sonar and ultrasonic scanners. We'll study about Doppler effect in sound and Doppler effect in light and applications of the Doppler effect. Now let us understand that sound is a form of energy and is produced by the vibration of bodies. Second thing is sound is propagated in the form of wave, just like the light wave, and it requires medium for its propagation. The speed of the sound is less than that of the light. It is 330 meters per second and has higher speeds in liquids and in solids. The frequencies that are capable of human hearing are called as audio or sonic. A wave is nothing but a periodic disturbance propagating through a medium. It carries energy along with it while it propagates. A wave has a frequency, it has got a wavelength and velocity. The relationship between the frequency, wavelength and velocity is given by V is equal to F into lambda. Sound vibrations produce wide range of frequencies. Human beings hear sounds of frequencies in the range of 20 Hz to 20,000 Hz. This range is called as audible range and the frequencies are called as audible frequencies. A small chart over here, you can see it. The human beings can hear right from 15 Hz to it goes on till 20,000 Hz. Similarly, if you look at some of the animals over here, you can see turtle can hear the lowest of 20 Hz, while the highest could be 1000 Hz. Pigeon actually can hear as low as 200 Hz and maximum can be 10,000 Hz. Coming to rabbit can hear right from 300 Hz to 45,000 Hz. So it means that it can even hear some ultrasonic sounds as well. Now coming to a cat and a dog, they can hear between anywhere in the range of 30 to 50 Hz to up to 50,000 Hz. Then you have got a bat. Bat can hear right from 3,000 Hz to 1,20,000 Hz, whereas a dolphin can hear right from 1,000 Hz to 1,30,000 Hz. Now let us come to the concept of understanding ultrasonic sound. Now ultrasonic sounds are nothing but the frequencies that are beyond 20,000 Hz. They are called as ultrasonic sounds. Now less than 20 Hz, they are called as infrasonic, or you can say subsonic sounds. You can see a small image over here. Now this is called a sonic range, that is between 20 Hz to 20 kilohertz, that is 20,000 Hz. It's called as sonic range. Now greater than 20,000 kilohertz, 20 kilohertz is called as ultrasonic range, and less than 20 Hz is called as subsonic, or it's also called as subsonic or infrasonic range. Now wavelength of the ultrasonic waves is right from 1.65 centimeters to 6 × 10 to -5 centimeter. Now this branch of science which deals with ultrasonic sounds is basically called as ultrasonics, and the speed of ultrasonic waves is the same as that of the sound, and it carries high energy because of its high frequency. Now this is the most important point. The ultrasonic sounds, they have got high energy because of very high frequency. Now let us try and find out some of the applications of or the uses of ultrasonic sound waves. Now these ultrasonic sound waves, they are basically used to know about the physical properties like elasticity, or it could be a configuration of atoms. It is also used in the manufacture of alloys and emission for photographic films. Ultrasonic sound waves, they are used in dry cleaning of clothes as well as to remove the grease and the dirt. They are used to check the crack and the flaws in the metals. They are used in welding, local heating and drilling small holes in the hard metals. They are used in sterilization process and also to kill bacteria. They are basically used in neuralgic and they are used in neuralgic and rheumatic pains. They are used in bloodless surgery as well. They are also used to break stones of kidney and gallbladder. Let us see some of the images over here. The first one being, it is also used in dentistry for the treatment of the cavities, as well as could be for an root canal treatment. Now next, coming to the next point, you can see it. This is a metal body. Now to detect a flaw in the metal or a crack in the metal, you can see it over here. Now these ultrasonic devices used. Now the ultrasonic device produces sound waves that are passed through the metal, and the moment it hits a hole or a crack, okay, or a void, and it is reflected back. Now this shows the presence of a flaw in the metal. Now We also saw that these ultrasonic waves are used to break the stones of kidney. You can see it over here. You can see the image of the kidney over here. Now these are the kidney stones. You can see it over here. The kidney stones over. Now these kidney stones are are quite large. To pass through the urine. Using an ultrasonic device. They pass an ultrasound shock waves that basically crush these stones. The stones are being crushed over here. You can see the ultrasonic shock waves that are being passed through the the body into the kidney, and these shock waves they crush the stones over there. You can see an image over here. Now the smaller pieces of these stones, now see the stones are broken into small pieces because of the ultrasonic shock wave, and now these are quite small enough to pass out through urine. Now that is how we know, you can take off the stones out of the kidney. You can see an example of ultrasonic welding. Now the horn applies a pressure. You can see the two plastics over here, plastic P1 and plastic P2. Okay, example of an you can say a local heating. The horn applies pressure to the plastic materials. Now this is a horn, it is applying pressure on this and this. Now because this horn vibrates at a rate of 20,000 hertz to 40,000 frequencies, and see the rate of vibration is between 20,000 to 40,000 times per second. Now that creates, this kind of vibration, they create a frictional heat on between these two plastics. You can see it over here. It vibrates at that range. You can see the vibration over here at that creates a frictional heat. Now that melts the materials. Because of the frictional heat produced, the material is gets melted, and they float together, and that's how the plastics can be joined. Here's one more example in how it is used to detect the flaw over here. The ultrasonic device, it uses a transducer over here, and it just sends the ultrasonic signals now that pass through the object, and wherever there's a flaw over there, it hits back. Now there's again a receiver at the other end. Now you can also see that the angle of incidence and angle of reflection, the difference between the two will help you to find out the location of the flaw. Now let us go to understand the next concept, that is sonar and ultrasound scanner. Now what is sonar? Sonar is nothing. It is sound navigation and ranging, that is called as a sonar. Now instrument or a device that will help you to measure the distance, the direction and the speed of underwater objects. Now this sonar is, as we told, it is a device. Sonar is a device that consists of a transmitter and detector. You can just see it in this figure. It has got a transmitter unit, and it is called detector or a receiver unit over here. That's one thing. The transmitter, it produces and it transmits ultrasonic waves. You can see high voltage pulse is transmitted. Now these waves, as you can see it over here, these waves travel through the water till they strike an object. The object is located somewhere here in the deep in the sea, and as soon as they strike the object, they reflected back. Because of the presence of the object, these ultrasonic signals are they reflected back, which are detected by the detector or the receiver over here. Now this is a receiver over here. This basically takes the time propagation, how much time it has taken to right from transmission to reception. Then the same is converted into electrical signals. You can see it here. There is a measuring unit over here, which can be interpreted very easily. The time interval between the transmission and the reception tell us the distance of the object. The entire process is called as an echo ranging. Now for example, if let the time between the transmission and the reception is t, and the velocity is v, then the distance d is given by vt in divided by 2. Now the entire method, as we told, is called as an echo ranging. Now it is basically used this look at distances as well as the icebergs and submarines in sea. You can see an image of that. You can see an image over here. Now I'll read for you. Now for example, the ship over here which is moving in the ocean, and it's doing an underwater survey also. Now as the ship passes through a survey area, now for example this entire area is a survey area. As the ship passes through a survey area, fan-shaped sonar beam, which is 4 times as wide as the depth of the water. It scans the seabed, and it takes many passes to produce a continuous set of images. Now you can see it over here. The winds bounce off the seabed and return to the ship where the echoes are recorded. That is how you can see the transmission and the reception of the signals happening. Now, there are some animals also which are able to produce ultrasonic sound waves. We can see a dolphin and then a bird over here. They are capable of producing ultrasonic sound waves, which pass through the water as well as the air. Now, the moment they hit the object, it reflects back. Now, that is how they come to know about their, about the object which is in between, or about their prey also. Let us go on to understand the concept of ultrasound scanners. Ultrasound scanners is actually an instrument that is used to get the images of the internal organs of the body. It is basically used in the medical field. Ultrasonic waves, they are directed to a particular area in the body, and these waves, they travel through the tissues in the body and they reflect back at a point when there is a change in the tissue density. Now that is how they are used in the scanning the internal organs of the body. Now, for example, you can say that the border between the two different organs of a body. Now, the scanner provides a display images in a static form, or it can be in a movie picture of inside body also. The ultrasound scanners are used in scanning as they are less harmful compared to X-rays. Now, the ultrasound images, they are analyzed. They basically analyzed to obtain the information regarding the internal organs. Now, this technique of ultrasound scanners serve as an invaluable diagnostic tool for examining the filled organs such as kidneys. It could be a bladder as well as the ovaries. This is also used to examine the heart, which is called as a heart and the heart diseases. That's called as an echocardiography. Also about the arterial system and the pancreas and the urinary tract. In examining of the fetus during pregnancy, and also used as a guide for surgical procedures. You can see the images of ultrasound scanner over here, as well as you can see how an ultrasound transducer, it is used in examining the fetus during pregnancy. Okay, now let us come to understand the concept of Doppler effect in sound and light. Look at the image over here. Now, we may have noticed several times that the pitch or the frequency of a siren of an ambulance drops abruptly. As for example, a person is standing over here and an ambulance is approaching him. So you can see the ambulance approaching him. Now, since the person is at rest and ambulance is approaching him, the sound waves produced by the siren of the ambulance, they get compressed between the person at rest and between the motion of the ambulance, and that is why we tend to hear sound at a very high frequency. Now, in the second case, you can see that the ambulance is moving away from the person who is at rest. Since the waves are moving away from the person, then obviously these waves will have a low wavelength and low frequency, and the frequency drops down and the sound apparently drops down. So we can define the Doppler effect as it is an apparent change in the frequency of the wave motion. It's an change in the wave motion due to the relative motion. There is a motion between the observer and the source. You can see the Doppler effect. You can see, for example, in the railway station. Now, if a person is standing in a railway station, now he feels a change in the pitch of the whistle of the train. You can see it over here, the movement of the train, the sound waves. For example, if a person is standing at a point A and a person is standing at the point B over here, and if the train is moving in the direction from A to B, the person A and person B both are at rest. Now, since the train is moving away from the person A, so it means that he hears a lower pitch of the sound, because the sound waves are stretched. You can see the sound waves are stretched over here. So obviously, you can say that it's of a long wavelength, and it becomes a longer wavelength and low frequency. Whereas since the train is approaching the person B over there, the sound waves are pushed together. They seem to be crushing, squeezing into each other, and he hears a higher pitch because of the high frequency and shorter wavelength. Now let us understand the next point. You can concept of a Doppler effect in light. Now, the speed of the light, for example, the speed of the light is so high that only celestial bodies or atomic sources moving at very high velocities, they show pronounced Doppler effect. Now, the observed effect consists of a shift in the wavelength of the light emitted by the moving celestial bodies. Now we can see it over here, the concept of Doppler effect. Now there are again two things which we understood, a red shift and a blue shift. Now let me just read it for you. Okay, now when a star, for example, if this is a star, when a star is stationary relative to an observer, if an observer, for example, if the observer is Earth, and if the star is stationary to the observer, the light produced by the, for example, this is the light produced by the star in all the directions. They look the same no matter what direction it is seen from, whether you see from this angle or you see from this angle or is from this angle. Okay, the light produced from the star will remain the same. The best example is our sun is a good example of a star because it is not moving much nearer or far from the earth. Now the next thing is, most important thing is, if the stars move either towards the earth or away from the vantage point, the motion shift the way their light looks us to us. Then the way the light emitted from the stars is seen to us, it changes. Now let us first understand the concept of a red shift. When stars move, when a star moves away from us, for example, you can see it over here, the star is moving away from us. When a star is moving away from the earth, it runs away from the light it emits in our direction. Now earlier if it was here, then the light emitted from it looked the same from whichever direction looking at. But since it is moving away from us, then we feel that it is running away from the light it emits in our direction. Now this makes the light wave to see the light waves we see expand. Now this is the reason why we can see, if you observe is over here, the light waves are getting expanded. You can see the wavelength, a longer wavelength in this case, as well as low frequency also. Now because the wavelengths are longer than the usual, the light shift towards the right side of the spectrum. The light, it moves towards the right side of the spectrum, and that is the reason why it is called as an red shift. The best example for this is the star called as Arcturus exhibits the red shift. Wavelength is changing, wavelength is becoming longer, the frequency is getting lower, and so that's why the light which is emitted, it shifts towards the right side of the spectrum, and that is why it is called as red shift. Now let us come to this point of understanding of a blue shift. Now when a star moves towards us, for example, if you are standing over here and the star is coming towards you, okay, it starts to catch up to the light it emits in our direction. Then you feel that there's so much of light coming. Then for example, if the source of light is coming towards you, then you feel there's so much of light coming to us. This makes the light wave we see contracted. You can see the light waves getting contracted, compressed. Now because the wavelengths are getting shorter, in this case you can see the wavelength are getting shorter and the frequency has increased. See, the light shift towards the blue side of the spectrum. The best example of a star doing this kind of thing is Sirius. Sirius is the star that exhibits blue shift. The most shifts, for example, but all these shifts cannot be seen with the naked eye. But astronomers can measure them to learn whether the other stars are advancing or they are receding. Now this is the best example of Doppler effect in light. The Doppler effect is also used. Let us see some applications of Doppler effect. They are also used, in basically to know about the velocity of the submarines. That basically called as an radar gun over there. Now, traffic control authorities, as you can see it over here. Traffic control authorities, they use Doppler effect to detect vehicles crossing speed limit. Radio waves are used for this purpose. You can see the radio waves. This is for example, a police van over here. Okay, this is a radar gun. What they have a radar gun over here. It's called as radar gun. The radar gun looks like this. This is an example of a radar gun. It is fitted into the vehicle. They basically use radio waves for this purpose. The radio waves, they are sent in the direction of the speeding vehicle. Now radio waves are being sent in this. This is a speeding vehicle over here. And the reflected waves are received. Now you can see the waves are sent. These are the waves that are being sent, and you can see the red ones as the waves are being received. The receiving waves are much shorter. Okay, the change in the frequency of the waves that is used in determining the speed of the vehicle. Now this instrument is called as an radar gun. The Doppler effect in light is also used to track the artificial satellites, the position of the artificial satellites also. You have seen it in radar gun, tracking of artificial satellites, and also in astrophysics. Doppler effect in light has many applications in astrophysics. It is used to study of binary stars, Saturn rings, galaxies. It is used to estimate speeds of the stars, galaxies, and rotation of the sun's disk. Thank you.